Earth's distance from the Sun isn't constant. It actually changes throughout the year because our orbit is elliptical. At its closest point, which is called perihelion, Earth is about 5 million kilometers nearer to the Sun than at Aphelion, its farthest point. This variation affects the solar energy we receive by roughly 7%, subtly influencing climate patterns. And here's a striking fact: Earth is actually closest to the Sun during the Northern Hemisphere's winter. Did you know that? What is perihelion? Well, Earth's journey around the Sun is far from a perfect circle. It's an ellipse, which means there are moments when our planet is closer to the Sun, and times when it's farther away. The closest point in this orbit is called perihelion, and it happens every year in early January. At perihelion, Earth is about 147 million kilometers from the Sun, which is roughly 5 million kilometers closer than average. This proximity means our planet receives a bit more solar energy during this time. On the flip side, aphelion is the point when Earth is farthest from the Sun, occurring around early July. Here, Earth is about 152 million kilometers away, making it the most distant it gets in its orbit. These changes in distance might sound like they would drastically affect our seasons, but surprisingly, they don't. Seasons are driven by the tilt of Earth's axis, not how close or far we are from the Sun. Still, the difference in distance does cause slight variations in the amount of solar energy Earth receives, which can subtly influence climate patterns. Over long periods, gravitational pulls from other planets slowly tweak Earth's orbit, changing the timing and shape of perihelion and aphelion. Understanding these points in Earth's orbit helps us appreciate the dynamic nature of our planet's path through space, and its subtle effects on our environment. What is aphelion? Earth's orbit isn't just about getting closer or farther from the Sun. It's a fascinating dance shaped by gravity that keeps our planet moving in an elliptical path. This elliptical orbit means that twice a year, Earth reaches two special points: perihelion, when it's closest to the Sun, and aphelion, when it's farthest away. Perihelion occurs around early January, marking the moment Earth is approximately 147 million kilometers from the Sun. This closeness means the Sun appears slightly larger in the sky and Earth absorbs a bit more solar energy. Conversely, aphelion happens around early July, when Earth is about 152 million kilometers away, making the Sun appear a little smaller. This difference in distance, about 5 million kilometers, might seem huge, but it only changes the solar energy Earth receives by roughly 7%. While this variation influences the intensity of sunlight, it's not the main driver of our seasons. That role belongs to Earth's tilted axis. Interestingly, the timing of perihelion and aphelion shifts slowly over thousands of years, due to gravitational nudges from other planets, subtly altering Earth's climate patterns over long timescales. Understanding aphelion helps us appreciate how dynamic and ever-changing our solar system really is, and how even small shifts in our orbit can ripple through the environment in surprising ways. Earth's orbital shape. Earth's orbit is often imagined as a perfect circle, but in reality, it's an ellipse, an elongated shape that creates fascinating variations in our planet's distance from the Sun. This elliptical orbit is the reason we experience perihelion and aphelion, two key points that mark Earth's closest and farthest positions from the Sun. At perihelion, which happens in early January, Earth is about 147 million kilometers away from the Sun, making it the nearest point in its orbit. This proximity means the Sun's rays hit Earth with slightly more intensity, but surprisingly, this doesn't translate into warmer global temperatures, because seasons depend on Earth's axial tilt, not distance. On the other hand, aphelion occurs in early July, when Earth is around 152 million kilometers away, the farthest point in its orbit. Despite being farther, this time coincides with summer in the Northern Hemisphere due to the tilt of Earth's axis toward the Sun. The elliptical shape of Earth's path causes about a 5 million kilometer difference between these 2 points, which affects the amount of solar energy our planet receives by roughly 7%. This subtle fluctuation influences climate patterns over time but doesn't dictate the seasons. Understanding the elliptical nature of Earth's orbit and the concepts of perihelion and aphelion reveals the intricate cosmic choreography that shapes our environment in ways many don't realize. When does perihelion occur? Every year, in the first days of January, Earth reaches a unique point in its orbit known as perihelion, the moment when our planet is closest to the Sun. This event might seem surprising because it happens during the Northern Hemisphere's winter, Yet Earth is actually about 5 million kilometers closer to the Sun than average, at roughly 147 million kilometers away. This proximity means the Sun's energy is slightly more intense, causing the sunlight to be about 7% stronger than when Earth is at its farthest point. However, this doesn't make winters warmer in the north because the seasons are controlled by the tilt of Earth's axis, not the distance from the Sun. Interestingly, perihelion also affects the southern hemisphere differently, as it occurs during their summer, making their summers a bit warmer and shorter. This subtle difference in solar energy influences weather patterns and ocean currents, contributing to seasonal variations around the globe. Over thousands of years, the exact timing of perihelion shifts due to gravitational interactions with other planets, slowly changing how Earth experiences these seasonal energy differences. Understanding perihelion not only highlights the dynamic nature of Earth's orbit but also deepens our appreciation for the complex factors that shape climate and weather on our planet. When does aphelion occur? Early July marks a fascinating moment in Earth's orbit called aphelion, the point when our planet is farthest from the Sun. At this time, Earth drifts to about 152 million kilometers away, roughly 5 million kilometers farther than average. You might expect this distance to bring cooler temperatures worldwide, but that's not the case. Aphelion occurs during the Northern Hemisphere summer, which is warm because of Earth's axial tilt, not its distance from the Sun. The Sun appears slightly smaller in the sky, and the solar energy reaching Earth decreases by about 7% compared to perihelion. But this difference is subtle and doesn't drastically change the weather. Interestingly, the Southern Hemisphere experiences winter during aphelion, making their winters a bit milder and longer. This variation in distance influences the distribution of solar energy, subtly affecting atmospheric circulation and ocean currents, which can impact weather patterns around the globe. Over thousands of years, the timing of aphelion shifts due to gravitational forces from other planets, slowly altering Earth's climate cycles. Understanding aphelion reveals how Earth's elliptical orbit creates nuanced effects on our planet's environment, highlighting the delicate balance that governs life on Earth. Distance differences. Earth's elliptical orbit means that the distance between our planet and the Sun isn't constant. It varies by about 5 million kilometers between perihelion and aphelion. At perihelion, Earth is closest to the Sun, around 147 million kilometers away, while at aphelion it's about 152 million kilometers distant. This difference might seem huge, but it only changes the solar energy Earth receives by roughly 7%. Despite this variation, the shape of Earth's orbit has surprisingly little effect on the seasons, which are primarily driven by the tilt of our planet's axis. Instead, the elliptical orbit influences subtle changes in solar radiation that can affect climate patterns over time. These small fluctuations contribute to phenomena like the slight difference in the length of seasons between hemispheres and variations in weather intensity. Over thousands of years, gravitational interactions with other planets cause slow shifts in the orbit's shape and orientation, known as Milankovitch cycles, which have played a role in Earth's long-term climate changes, including ice ages. Understanding the distance differences at perihelion and aphelion helps us appreciate the complex factors that shape Earth's environment and reminds us that our planet's journey around the Sun is a dynamic and ever-changing process. Effect on Earth's seasons. The changing distance between Earth and the Sun during perihelion and aphelion might seem like it would have a huge impact on our seasons, but that's not the case. The real reason we experience seasons is because Earth's axis is tilted about 23.5 degrees relative to its orbit. This tilt causes different parts of the planet to receive varying amounts of sunlight throughout the year, creating the familiar cycle of spring, summer, autumn, and winter. Even when Earth is closest to the Sun at perihelion in January, the Northern Hemisphere is tilted away, resulting in winter there. Conversely, during aphelion in July, Earth is farthest from the Sun, but the Northern Hemisphere is tilted toward the Sun, producing summer. This axial tilt also explains why the Southern Hemisphere's seasons are opposite to those in the North. While the elliptical orbit does cause a small difference in solar energy, about 7% more at perihelion than aphelion, this variation is overshadowed by the effect of the tilt. However, the orbit's shape does influence the length and intensity of seasons slightly, contributing to subtle climate variations over time. So, understanding the distinction between the effects of Earth's tilt and its orbital distance helps clarify why seasons happen the way they do, highlighting the complex interplay of factors that govern our planet's climate and weather patterns. Impact on solar energy received. The amount of solar energy Earth receives changes slightly between perihelion and aphelion, and this subtle shift plays a role in our planet's climate system. When Earth is at perihelion around early January, it absorbs about 7% more solar energy than at aphelion in early July. This increase might seem small, but it can influence atmospheric circulation patterns and ocean currents, which in turn affect weather and climate around the globe. For example, the Southern Hemisphere experiences slightly warmer and shorter summers during perihelion, while the Northern Hemisphere's summers during aphelion tend to be cooler and longer. These differences contribute to the uneven distribution of heat across the planet, impacting seasonal weather variations. Over time, these small fluctuations in solar energy can amplify or moderate climate phenomena, such as monsoons, droughts, and storm patterns. Additionally, the elliptical orbit's influence on solar radiation interacts with other factors like volcanic activity and greenhouse gases to shape Earth's complex climate system. Understanding how the changing distance between Earth and the Sun affects solar energy helps us grasp the delicate balance of forces that govern our weather and long-term climate trends. This knowledge is crucial for scientists studying climate change and predicting future environmental shifts, highlighting the intricate connection between Earth's orbit and life on our planet. Influence on climate and weather. Earth's climate is shaped by many factors, and one of the less obvious but important influences is the subtle variation in its orbit caused by perihelion and aphelion. These points mark Earth's closest and farthest distances from the Sun, and over thousands of years, gravitational forces from other planets cause slow but significant changes in the shape and orientation of Earth's orbit. This phenomenon, part of what scientists call Milankovitch cycles, affects how much solar energy different parts of Earth receive during various seasons. These orbital changes have been linked to long-term climate patterns, including the timing of ice ages and warmer interglacial periods. When Earth's orbit becomes more elliptical, the difference between perihelion and aphelion distances grows, amplifying seasonal contrasts. Conversely, a more circular orbit reduces these differences, leading to milder seasonal variations. Understanding these orbital shifts helps explain why Earth's climate has fluctuated so dramatically over geological timescales. It also highlights the delicate cosmic interplay that influences our planet's environment far beyond daily weather changes. Recognizing how perihelion and aphelion fit into this broader picture deepens our appreciation for the complex forces shaping Earth's past, present, and future climate. Why Earth's orbit changes over time. Earth's orbit is not a static path, but a dynamic journey influenced by countless cosmic forces, and understanding perihelion and aphelion gives us a glimpse into this celestial dance. These points mark the extremes of Earth's elliptical orbit, shaping how much solar energy our planet receives at different times of the year. While the variations in distance might seem minor on a cosmic scale, their effects ripple through Earth's climate system, influencing weather patterns, ocean currents, and even long-term climate cycles. Over millennia, the shifting timing and shape of perihelion and aphelion, driven by gravitational tugs from other planets, contribute to the natural ebb and flow of ice ages and warm periods. This ongoing orbital evolution reminds us that Earth's environment is part of a vast, interconnected system where even subtle changes can have profound impacts. By exploring these orbital points, we gain a deeper appreciation for the complexity of our planet's climate and the delicate balance that sustains life. So next time you feel the warmth of the sun, or notice the changing seasons, remember that Earth's position in its orbit, whether near perihelion or aphelion, is one of many cosmic factors quietly shaping our world. Thanks for watching this deep dive into Earth's perihelion and aphelion here on InnoVision Tech. If you enjoyed uncovering how our planet's orbit shapes climate and seasons, don't forget to hit that subscribe button and ring the bell so you never miss our latest tech and science insights. We'd love to hear your thoughts. Drop a comment below with your questions or what topic you want us to explore next. Join the InnoVision Tech community, and let's keep exploring the future of technology and discovery together.